Najla Vedina from the Department of Architecture, Program International.
Hi, I'm Chaidar Nadif from the Department of Metallurgy Material, Program International.
Hello, I'm Yusuf Ghozal Ghurfata from Industrial Engineering major.
Hello, my name is Vanissa Aulia S and I'm from Architecture International Program.
My brain is about to explode. I'm so confused about derivatives. Please, can there be someone who will come to my aid? Oh, what's this? Need help for derivatives. Call us.
Hello class, so for today's session I will be teaching you about maxima and minima as a concept that is the subtopic to derivatives. So as the name suggests, it is finding the maximum and minimum value of a given function. So to further elaborate this point, I'll be giving you an example. And for this example, I'll be focusing on the maxima, or the maximum value of the function. So for this example, what is the value of the function x minus 1 multiplied by x minus 2 squared at its maxima? And first and foremost, you would want to write the given again in a better form in order for you to solve it. So instead of writing function x minus 1, x minus 2 squared, you would write function as fx, which you also read as function, equals to x minus 1, x minus 2 squared. And afterwards, since the x minus 2 is squared, you would obviously need to square it, and you would square it using the FOIL method. And after doing so, you would get fx equals to x minus 1 multiplied by x squared plus 4 minus 4x. And afterwards, fx is equals to x cubed minus 5x squared plus 8x minus 4, which is the answer to multiplying x minus 1 multiplied by x squared plus 4 minus 4x. And afterwards, you would need to find the derivative of that said function. And the derivative of x cubed minus 5x squared plus 8x minus 4 is 3x squared minus 10x plus 8, so the minus 4 is irrelevant at this point. And in order to solve this function and find the possible values of x, in order to get the value of x, or the values of x, you would need to make the equation equivalent to 0. So you need to write 3x squared minus 10x plus 8 is equal to 10. And afterwards, you could factorize the said equation, and you would get 3x minus 4 multiplied by x minus 2, because if you distribute and do the FOIL method like before, you would get the answer. And afterwards, in order to get the values of x, you would need to look at the values one by one in the parentheses. For instance, you would need to look at 3x minus 4 is equivalent to 0, so when the 4 is moved on the other side, and if both sides are divided by 3, then you would get x is equivalent to positive 4 over 3. And same with x minus 2, you move the 2 to the other side, and it becomes x equals to positive 2. And afterwards, you need to find the derivative of the derivative that we just found, which is 3x squared minus 10x plus 8. And the derivative of that is 8x minus 10. So this time the plus 8 is the one being unused. And afterwards, you would need to put the values of x into the function in order for you to determine whether or not it is the maximum or minimum value. And since this is asking for the maxima, we are looking for the maximum value in here. So we put the values 4 over 3 into the function 6x minus 10. And you also do that with 2. And with that being said, the result is for 4 over 3, the function is negative, or it's below 0. And if we use 2, then the answer would be over 0. It would be 2. Hence, when x is 4 over 3, the function will occupy the maximum value. And the maximum value here is function 4 over 3 is equivalent to 4 over 27.
Okay, so since we've learned about what maxima and minima is, today we are going to study and learn the real-life examples of it. So as we know, maxima and minima are the maximum and the minimum value of a function. I'm going to demonstrate a few examples of its use in real life. The first one is a farmer with a length of L foot of fencing material trying to enclose a rectangular field of maximum area with one side bordering a river. It doesn't have to be a river, but for this case it is. I'll try to illustrate it. So let's say this is the river. This is the river, and all of this is the field. He only has L length of fencing material, so this is L. let's just say L could go like this, or L could go this, but that's just a waste of material. What is the maximum area that could be covered by that length? That could be found using the maxima and minima, the maximum and minimum of a function. So yeah. And for the next example is a store manager trying to maximize his profit or minimize his losses by estimating prices for items and also how many to keep in stock. This is the same case in economy. We see a lot of parabolic diagrams and graphs in econ. So it's the same in business. A store manager could predict or calculate how much to produce for the most optimized results and profit.
Hello! So next I'm gonna teach you about antiderivatives. What is antiderivatives? Antiderivatives are the opposite of derivatives. An antiderivative is a function that reverses what the derivative does. One function has many antiderivatives, but they all take the form of a function plus an arbitrary constant. What are the examples? Here is one of the examples. So before going to the examples, first I want to tell you about the formula of antiderivative. So the formula of antiderivatives is x to the power of n plus 1 divided by n plus 1 and plus c. So the example, find the antiderivative of x to the power of 9. So based on the formula, we can use x 9 plus 1 divided by 9 plus 1 plus c. So it is x to the power of 10 divided by 10 plus c. There you got it, you guys. This is the answer. Simple, right?
So now I'm going to talk about antiderivatives. Now antiderivatives are quite literally the opposite of what derivatives are, right? So if we keep this in mind, or if we kept that in mind, right, we can solve, antiderivatives in a way where, for example, right, let's say we all know that the derivative of fx is going to be f prime x, or f prime x. I'm sorry. And then the derivative of, and so basically the antiderivatives of f prime x is going to be f of x. Now we also have the Riddler's number. If let's say the derivatives of f of lowercase f x is gonna be the the antiderivative of this is gonna be f capital X plus c. So to recap, or to summarize, basically the fx is gonna be the antiderivative of fx of fx of f lowercase x, whilst fx is going to be the antiderivatives of f prime. Now, to put it simply, let's say we have the second derivative of fx, and antiderivatives, it goes up the scale. I guess it's not a scale, but it's a more visual way of representing it. It's going to be f prime x, and then it's gonna be f lowercase x, and then it's gonna be f uppercase x. Where that's antiderivatives, derivatives goes down the scale. Derivative goes down it. So yeah, I guess you can tell where that's gonna go. So now I'm going to let's do some problem questions, right? We all know that again, let's say the derivative of x cubed is gonna be 3x squared. Now to find and the rule for this, or the rule for the derivative is for this case is, well, I think we all would know, it's gonna be x of a component is gonna be the n times x power to the power of n minus 1, and this is the this is if you derive, this is where this derived from. Now for antiderivative, it is going to be a bit different, where in a way where it's x n times dx is equals to x per n plus 1 over and x is going to be also over n plus 1 plus c. So again, this is just the opposite of what's this doing, right? So let's take in, for example, let's take this and try to put it into an antiderivative. So the antiderivative of x, 3x squared dx is going to be 3 times x, and 2, right? 2 plus 1 over 2 plus 1. And by the result, we can get 3x, 3 to the power of 3 over 3. And in this case, we can just cross these two out, and then we are going to be able to get the antiderivatives of it, which is going to be x cubed plus c. And if you do want to check, right, we can just put this into a derivative, which is going to be 3x squared plus 0 or plus nothing. So yeah, this and this is the same. So with that in mind, let's try some more practice questions. Say x cubed per dx. So in this scenario, again, using the rule of x n plus 1 over n plus 1 plus c is going to be 4. So x times, in this case we don't have any numbers, so we're just going to put it simply. So x 5 plus c over n plus 1, which is going to be 4 plus 1, which is going to be 5. And let's try to do this. X 7 dx, it's going to be x plus 1 again plus x n plus 1 to the power of n plus 1, which is going to be x to the power of 8, or 7 plus 1, or 7 plus 1 over 7 plus 1, which is going to be x to the power of 8 over 8 over 8. And let's do one more example of this. Let's say that it's let's say this is going to be 3x6, right? And the antiderivatives of that is going to be 3 times x, x plus 1, or it's going to be 6 plus 1 over 6 plus 1, which is going to be 3x to the power of 7 divided by 7. And because we can't really make this smaller, and yeah, that's gonna and like that. So that's it for antiderivatives, and I think that's it for me. I'm Haidar, and I'm signing off.